Can we go live? Okay, I think we are live. So, good afternoon. Hi, Anvesha, Hamid Kader Ali, Dr. Hamid Kader Ali. Are you a doctor, physician, Hamid? If that is the case, I'm so proud that doctors are taking my course. I'm an engineer, so obviously you are saving lives. You are a real doctor. So happy. Anvesha, thank you so much for joining again. So good to see you. You have a good question. Actually, we have a nice video. Unfortunately, I don't think we can. I don't think we can play the video now. But what I can do is hi Prasad Gainivar. What I can do is that I can ask your TA to share that video. So this is a prank that we played that one of the students played in our campus. I'll tell that little story. So her question is, Anvesha's question is, a monkey experiences fear the first time it sees a snake. This is because natural selection has led to monkey having an instinctive fear of snake, or the monkey has learned to be beware of snakes. But I think it's a combination. I mean, it's not just snake. It doesn't know a snake for a snake when the monkey sees the snake for the first time. It doesn't know that it's a snake. But what it does know is that this is something that is slimy and, not particularly harmless. It's likely to be harmful is an idea that the monkey probably knows. Not necessarily with respect to snake. Anything that moves like a snake will also scare the monkey. Not just so it's not like By the way, not all snakes are dangerous. So it is judging that based on the movement that the snakes are making and the appearances that is there. But probably there is an amount of evolutionary there has to what genes are encoding these kind of things. The fear pathways. I think that's beyond the scope of our course. But these are interesting questions. By the way, since this question has been asked, I will yes, Hamid. Good afternoon. Thanks. By the way, thanks to for all of you for waiting. You waited for a few minutes. I am aware of that. We are having this is the rainy season in Chennai. It lasts exactly for 5 days. I mean, I'm just kidding. This is supposed to be the rainy season. I just started and got caught up in the rain, but somehow made it finally. That's okay. Anyhow, thanks for your patience. So regarding the monkey snake problem, coming back to the monkey and the snake problem, I think in 18 or 17, I do not remember which year, probably 18, I had a student from our institute when this course was started, in the real mode to the IIT Madras students. One of the undergrads, what he did, he put a fake snake, and so we have a lot of monkeys on campus. In case you didn't know, our campus is a beautiful campus containing wildlife, monkeys, deers, and blackbucks and dogs. But talking of wildlife, dogs don't count as wildlife. But we do have deers, monkeys, and blackbucks. So these monkeys are a complete menace in the hostel zone everywhere. Actually, residential zone, hostel zone, academic zone, everywhere. So they know what kind of boxes or bags are likely to contain food. So if I'm taking a bag, they know this is the academic bag. It's unlikely that this fellow is going to have food in it. But then they can differentiate the food bag from a non-food bag. Very smart monkeys. These are the IIT monkeys. So this student, he put a fake snake, a rubber snake type of thing, in a sweet box. The Krishna Sweets Mysore Pak box. It's famous in Chennai. If you come to Chennai, it's something that you taste. There's some sweet box. Doesn't matter what. Some sweet box. In that box, he put a fake snake, and he kept it so that it is accessible to monkeys. And then he videographed the whole you know, situation, the whole thing. What happened was that the monkey came in and saw the sweet box, and it's very eager to open up the sweet box and say, and as soon as it opened, it made a huge jump and ran away from that place, thinking that it's a real, thinking that it's a real snake. His question to me and the rest of his classmates was, what kind of response is this? Is this a voluntary response, or is this a reflex, or is this a pre-programmed reaction? This was the question that the student asked. Then we had a debate as to what kind of movement is that, what is the response of the monkey, and this, it was phenomenal. That's a very nice, experiment and designed. By the way, I did not ask him to do this experiment. Okay, I mean, this was done by the student on his own voluntarily. But anyhow, now that he has done the experiment, we were interested in analyzing the data. We didn't get any permission for doing this experiment or anything. That's just fun and experiment that the student decided to do on his own. So we had a discussion at some point within the class for quite some time, and we kind of concluded that this is actually a pre-programmed reaction, meaning that it's crystallized. It's something that is, inherent, natural to the monkey to jump away when it sees a snake. And I will ask your teaching assistant to share this video with all of you in the forums. Okay, Prajwal, kindly share that video with all the students. I think the original video is with Anurag. I think Anurag has the original video, and you can collect it from him and share it in the forum somehow. Maybe we can upload it somewhere and then share the link, maybe. Something like that. So what we learned from that experiment was that the monkeys do indeed respond quite soon, quite fast. It did not appear like a voluntary, rational decision-making type of thing. It appeared more like a reflex and more like a pre-programmed reaction. So I didn't think that it was. By the way, it's very difficult to time that this, because it was videographed using a regular phone camera. So we really couldn't exactly time the stimulus versus response kind of. It's not a proper lab experiment. But my sense is that the response was more than 30 milliseconds, probably like 70, 80 milliseconds. So more like it's a pre-programmed reaction. So that means that it's likely that it was it's naturally encoded. It's a natural fear response. As to, if your question is as to what are the pathways that mediate this fear response, that's a different topic. That's a huge topic, still under active research, but that's also beside the scope of this course. We can definitely have a chat after the, offline, we can definitely have the class. In the meanwhile, I have some questions submitted by you. A lot of questions actually. Quite a few questions from Anvesha. I'll come back to all of them. But first, a question from someone who is not Anvesha, Kirtika. But there's no question from her. She says no question. She says she will attend the meeting. There are other questions. If there are other questions, Anvesha has one more question. I'm not able to. For producing large force, we need to recruit the weakest to strongest neuron. Small to large following size principle. Isn't this a wastage of cellular ATP when it comes to producing large with minute precision? Well, actually, large forces, you cannot have minute precisions in large forces. Usually, large forces come with relatively large precisions. So, I'm saying this based on experience, I've been researching this for the past 14-15 years. So, based on that, you need to take my word on that. But you can check this. This is data from Schmidt, 1975, Richard Schmidt, the so-called the author of the motor learning, the first textbook, Richard Schmidt, 1970s, 75 or 76, I think, and also later popularized by the Harris and Wolpert paper on signal dependent noise. Right, so as the force level increases, usually the variability increases. That's because you actually cannot have both precision and large amplitude. It's these two things are usually incompatible in the healthy motor system, usually. So if your question is, why do you have to do this like this using size principle? This doesn't make much sense, because if I have to anyway produce a large force, why do I have to take step-by-step approach? Well, if you are saying this is a wastage of resources, consider that you cannot have everything. You cannot have the versatility that you have in terms of choosing the specific force that you want, and also have the precision that you want, and also have the efficiency that you want. You need to compromise somewhere. So in this system, the compromise is made. There's so many times we think that it's an optimal system. Actually, many human behaviors cannot be class. Some human behaviors are optimal, but not all human behaviors are optimal. So many of these things are not necessarily optimal or efficient or anything like that. Actually, usually these are non-optimal and not necessarily super efficient. They work somehow. So many times, it comes down to survival, it comes down to stability, and those things. Those are the things that, that Trump, not the President Trump. I mean, I'm not getting into that fiasco. I'm saying that, stability, survival, and those things, supersede the importance for efficiency, optimality, and these things in many cases, but not all cases. Okay. Another question, how innervation number changes with population? Also, does vestigial organs have any connections with the motor neuron being dying or get orphaned? So I think this was also discussed in one of the videos where we discussed this innervation number versus that it changes with population. How does this happen? So what happens is that as you age, what happens is that some of the motor neurons die. As to why this happens, we do not understand. Healthy aging. This is, by the way, for aging can be defined as people who have diseases and are old, and people who do not have diseases and they are old. I'm talking about people who are healthy but old. In those people, even in those people who do not have diseases, motor neurons die off for whatever reason, because of these topics such as to why this happens. These are huge topics. Then it raises the bigger question as to why do we age? Why do we become older? But there are lots of theories that talk about why we age. By the way, aging has multiple dimensions: aging of the body, aging of the brain, aging of various different things, and aging of the mind. So many different things. So some people even say, philosophers say that aging is essentially death personified. You're slowly, whatever. There's a huge topic. But I'm talking about people who age healthily. In these people, some motor neurons die off. Then what happens? The corresponding the muscle fibers that are innervated by these motor neurons will become orphaned. Then what happens after some time? Not immediately. After a few weeks or a few days to a few weeks, the neighboring motor neurons take over these muscle fibers. Now that means that if the neighboring motor neurons already had a smaller innervation number, the new innervation number is likely to be large. That means what? That means people who are older are likely to produce larger forces, and that makes sense. Now that is a hypothesis that you can make and test. Is this true? can we check if people who are older necessarily produce large forces than required to accomplish motor tasks? That is a hypothesis that you can make, and people have made that hypothesis and tested this hypothesis, and experimentally it has been found that this is indeed true. If you need to produce X newtons, to accomplish a motor task, people usually produce X plus Y newtons, Y being greater than 0. Some non-zero additional force they produce to achieve this. So if the question is, why does this happen? Why does this happen? That I do not know. That's like I said, that raises a bigger question. So the other question, I think this student is a good philosopher. Her question is, at rest state, action potential signifies what? Neurons seem to engage in propagation of signals even when we are in sleep. Does at rest condition signify death? This is the question. Well, like I said, this is something that I mentioned in the action potential video itself. What is action and what is rest? In that video, I mentioned this. Rest state is that state that is present between two action states, and action state is the state that is present between two rest states. Permanent rest is death. So it's not clear what is rest state. When do you call someone as stopped moving? I mean, probably when they die. But then even after death, some movements remain not because of motor neuronal. This because of muscle tightness, rigor mortis, and all those things. But essentially, the lack of movements to a large extent signifies death. So when you say rest, what is meant is the state that is present between two actions. But then that doesn't mean that when you are taking rest, when you are sleeping, all the motor neurons or all the neurons in your body are resting. Sleep is a very, very complicated topic. Like she mentioned that one half of the body is sleeping, one half of the brain is sleeping, the other half is sleeping. One set of neurons are taking rest while the others are taking over, and this again sleep is something that we have not really understood well enough. It seems like every time when you are asking a question, I am telling you that, oh, by the way, this is not well understood. I hate to answer questions like that, but you all know that I am honest with all of you. I need to tell you the state of the field so you can actually learn from this and try to improve the field. I am inviting all of you to be co-workers, collaborators, and colleagues who will work in the field, who will contribute for the development of the field. For you to do that, you have to understand the actual exact state of the field. If we are not doing well, you need to know that we are not doing well. That is the beginning of wisdom. So coming back, so actually we do not understand how sleep works, unfortunately. So what that means is essentially that when you are sleeping, it doesn't mean that all your cells are sleeping and all your neurons are sleeping. Probably they take turns. As to how exactly that happens, people are still actively researching. Okay, but when I was in Penn State, where I did my PhD, one of my professors was David Rosenbaum. So David has this theory that he discusses frequently. He gives speeches on this topic. He calls this as the end state comfort. Okay, I'll type that out for you. It's called as the end state comfort theory. So we used to question him as to David, what do you mean by end state? For some of us, end is death. There is no such thing as end state. The theory goes as following. Suppose you have a glass. Let's think that this object is a glass, okay. And this is the top of the glass and this is the bottom of the glass. Okay. And let's say that I have kept the glass upside down. Okay. This is how glasses are kept in, say, a bar, for example. You want to pick it up, and when you want to pick it up, you will never pick it up in the straight way, because you will later have to turn it around to pour the wine or whatever the drink in it, right? And that state is a relatively awkward posture. Look at my arm; it's an awkward posture. And the theory is that you are interested in keeping the end state in a more comfortable posture. Because of that, if the top part is facing down, when you are picking it up, during approach you will go with an awkward position. So at the end state you will be more comfortable. This is the theory, for example. It's a nice theory. Hundreds of papers have come out on this topic, but we always simply used to give some difficulty to David Rosenbaum in asking him, no, what do you mean by end state? What is the meaning of this? End state is when you are dead. Even when I am sleeping, I am moving. I am moving all the time. Even before I am born, I am moving. Even after death, I am moving. What do you mean? End state. What is end? There is no end. There is an end when we end. And things like that. So these are philosophical questions, right? So just saying. Those who are interested can check that out. This end state question. End state comfort. Then the next question is, for each muscle fiber, there is one motor neuron commanding it. But one motor neuron can command multiple muscle fibers. In case of crisis situation where a movement needed to perform rapidly, can more than one motor neuron command each muscle fiber to generate greater output. Coordinated muscle activity is predicted by population of neurons. Georgopoulos experiment. Yes, so if your question is, the question is, one motor neuron connects to n number of muscle fiber, but a given muscle fiber can be commanded by only one motor neuron. The question is, but suppose I am interested in producing a larger force in a faster manner. Can I not suddenly change an innervation and command parallelly so that I will get a larger force? Can I not do that? The answer is no. Why not? If I say no, immediately the student will ask, why not? Because it requires a physical branching, physical innervation. It's not a computer program like we do. It's not like, I'm writing a computer program, I'm just saying, okay, if there is a rapid situation, you please execute this program. It's not like that. Neurons actually need to innervate. When I say innervate, there is a branch of an axon that delivers the acetylcholine to the muscle fiber, to the nicotinic cholinergic receptor. This must happen. For this to happen, you cannot suddenly change the code. This will happen. For example, in renervation type of situations, this does happen, but it doesn't happen in zero time. So this is not something that can be changed on the fly. It can be changed in some cases under some special circumstances, but does not happen on the fly. So no, we cannot do that. Then you are asking, so that means when I am in an emergency situation, I need to produce a relatively large force within a relatively short period of time. Can I not do that by actually using all the facilities that I have? Unfortunately, the answer is yes. Unfortunately, we cannot do that. We can only do what we can within our limits. So it's important to know what our limits are. So this is not possible. Okay, but what is possible? What is possible is desynchronized or synchronized force production using multiple motor units, and motor unit managing motor unit redundancy and other such things are actually possible. Unfortunately, humans as a species, not just humans, all these animals know their limitations and they try to work within their limitations. And if we cross that limit, usually we end up with an accident, we end up with an injury. We better learn the lessons. Okay, so many of these things are shaped by, as the student pointed out, as Anvesha pointed out, many of these things are shaped by a combination of both nature and nurture. So we do have this crystallized, pre-programmed, nature-selected, thought of how to approach a problem situation, but we also learn through life situations. Gravity and other such problems, gravity and other such things, we learn by behaving, by actually, it's not like, you never fall down when you are walking. A child falls down many times before they walk steadily. But actually, even adults fall down. Even we fall down. It's not like we never fall down. By the way, falls in older adults is actually a serious problem. So it's not like, then your question is, are we not learning? We are, but we haven't learned every practical situation. We are learning, but that can also be applied not just to motor learning. That question can also be applied to, cognitive and executive and associative learning problems. We are making the mistake and we tell ourselves, oh God, I will never make this mistake again. For example, let's say, for example, you have this bad habit of reading for an exam in the last minute. By the way, that's a bad habit. Let me tell you, for the Neuroscience of Human Movements course, 140 students, I'm happy to note that 140 students have registered for the exam. I expected this number to be more, but that's okay. The 140 who have registered, please let us prepare for the exam together and let's do this exam well. And when you prepare, remember one thing, we are students of neuroscience and we will follow principles of neuroscience to write the neuroscience exam. What that means is that, we will prepare for the exam well in advance and we will sleep the night before the exam. But suppose you have this bad habit of preparing for the exam in the last minute, on the last night. Every time you do this, you will tell yourself, trust me, you please ask yourself this question, not just this. Let's say you have a drinking problem, you have some problem that you are yourself not happy. You don't have to tell me what it is. But the truth is that you have this problem. And every time after a night out, you feel, God, I'm never doing this again. For the next exam onwards, I am going to prepare well. And well in advance, and I'm going to sleep on the night before the exam. Yet, the next time, you end up, doing this. So learning, then the question is, what are you learning? Are you learning at all? If you are learning, then you must be improving, right? Where is the improvement? So this is a problem that's not specific to, this is not exactly a motor, related problem. It's a multidimensional problem. But my point is that this is something that is present in many dimensions of learning: cognitive learning, associative learning, executive learning, and so on and so forth. And in all these cases, we are learning machines. We are learning engines. Our brain is probably the most wonderful and the most advanced. The human brain is probably the most wonderful and the most advanced learning machine. So we keep learning. My grandfather is 96 years old and he still keeps saying in Tamil, he keeps saying Buddhi Kolmudal. What that means is that, I am still learning. I then asked him one fine day, and he told me recently that he is still learning. I asked him, what are you going to do with that learning? You're 96 years old. It's not like you're going to, use this learning anywhere. Perhaps you don't have to learn after this. Perhaps you can simply stop learning. Think about it. I'm right. I'm practical about this. After 96, where are you? What is the likelihood that you're going to actually apply your, learning? For example, he said, "Oh, we have to keep learning. Till the last day, I had to keep learning. I cannot afford not to learn." Now that is the thing with humans. That is the thing with biological systems. We are excellent learning machines. We continue to learn. So it's a combination of nature and nurture. So, I mean, it's natural selection that some of it is, ingrained genetic and all that. Some of it we learn and we keep learning. And this learning is getting refined. What we think is, is something that is clear today. As we go in deeper and deeper, becomes less and less clear. What we think is less clear becomes clearer and clearer. All these are dimensions and aspects of learning. So, that's what we keep doing. So I think I have answered all the questions in the Excel sheet. Yeah, I think I have answered. Yeah. So this learning will also probably the likelihood. Also probably results in changes in the neuronal structures. Probably strengthening of synapses are reducing the strength of synapses is probably what is going on, is the leading popular hypothesis. But if that is the case, by repetition of by repeating a particular task, strengthen synapses that are engaging that task. If, for example, if that is the case, then if you're making mistakes again and again, then the mistake pathway will become more and more crystallized. No. So this is it's not my question. This is the question that Bernstein asked. Let's say that you have a child who has never walked earlier, and this child is attempting to walk. And for the first 15 or 20 times this child is making the first step, she is falling down. Okay. If each repetition crystallizes or strengthens the synapses associated with the motor neurons and all the neurons in that pathway, strengthens and a long-term potentiation of the synapses are happening in that pathway, then the question is, since she is making this mistake, what will become more and more crystallized? The mistakes, right? Not the correct movement. Yet, at the 21st move or the 29th move, this little baby, she is able to take her first step correctly. So it's not clear what exactly is the mechanism of this learning. These are leading hypotheses as to what is going on. There are lots of hypotheses. And again, this idea that there is localization of function, there is this this kind of learning is mediated by these areas, are all excellent theories, excellent hypotheses, but we only learn so much from these. I'm not saying they are useless; they are useful, but there is a limitation as to how much we can learn from them. In neuroscience, everything is complicated. In biology, everything is complicated. Especially in neuroscience, we know so little. The Candle and Schwartz book, the size keeps increasing, but the theories to understand neuroscience, the theory is a universal theory of behavior, neural behavior, is something that has eluded it for the last several centuries. Well, if we can fix this problem, what Eric Kandel, the author, Nobel laureate Eric Kandel, the author of Principles of Neuroscience textbook, says is that there must be a neural basis. There is a neural basis of consciousness. There must be a neural basis of consciousness. Or there is a molecular basis of consciousness. There must be a molecular basis of consciousness, is what he says. But if we can crack the molecular basis of consciousness, that would be probably the greatest scientific advancement ever. If we can crack that problem, we have not cracked that problem, unfortunately. So this is a field in its infancy. We are taking our very, very early baby steps, like that baby I gave in the example. So we are really in a very early stage, which is why I'm inviting all of you, those who are watching this video, those who are taking the course, those who are taking the exam, all of you, to become students of this discipline, to become scholars of this discipline, to become teachers of this discipline, so we can all push this forward in a big way. And in the way this will help hundreds of people who are suffering from neuromotor disorders. If you are asking, hey, can I make a lot of money with it? The answer is, I actually don't know. Maybe yes, maybe no. But what I can assure you is that you will have a very fulfilling, very satisfactory, very gratifying life, very peaceful, and very satisfactory life of having actually helped people. At the end of the day, this is something that we all want, not just money. I'm not saying money is unimportant. Let's not get into that debate. And this is so, which is why I'm inviting all of you to be part of this community that is interested in neural control of movement. There are quite a few programs in India. At some point, I'll discuss the work done by my colleagues all over the country. Also, the work done in my lab at some point. Maybe not right now, but we are. So, yes, please welcome. So there is a question here. Lynn Isabel, anthropologist, concludes that. Lynn Isabel, anthropologist, concludes surviving the jeopardy of snake for millions of years required selective pressure favoring primates, specialized visual systems, the pulvinar region of the brain. Perhaps this is true. Perhaps this is true. I am not aware of this literature. I can check it. I am not aware of this literature. Sadly, every time Anvesha is throwing a paper or some finding at me, and I'm immediately saying, "Oh, is this true?" I'm not aware of this literature. She might be thinking, "What kind of neuroscience expert is this guy?" Every time I ask him a question, he says he has no clue. That's because it's a huge field. Neuroscience is a huge field. I attend this Society for Neuroscience meetings that is attended by 45,000 other colleagues every year. It's a huge field. It's a really huge field. And I am in a very so, and also for you to contribute positively to a field, you need to narrow down the area in which you work. So there is only so much you can do. But of course, as students, students like Anvesha, you have plenty of time and opportunity to explore multiple things. But people like me who have chosen a career keep, people who like me who have chosen a career keep pushing in a relatively small direction, in a small area. Like I said in one of the quotes that I mentioned to my students, to my research scholars in my lab some time ago, I mentioned an expert is a person who has found out by painful experience all the mistakes that one can make in a very narrow field. Who said this? Any idea who said this? An expert is a person who has found out by painful experience all the mistakes that one can make in a very narrow field. This was said by Nobel laureate Niels Bohr. Okay, so if you want to become an expert, you go through this painful process of mistakes and learning. And this is obvious, no pain, no gain. But actually, when you are going through the pain, especially the growth pain, any kind of pain is something that we don't want. No, especially in today's world, nobody wants pain. But unfortunately, no pain you cannot gain. No growth without pain. There are like they say, I don't know, this House of Cards quote, there are two kinds of pain. The pain that helps you grow and the pain that is simply pain. The useless pain. I have no respect for useless pain, is what that guy says. So like that, the pain that helps you grow, the pain that makes you stronger are the pains that we want to take. Of course, it's not clear what is that pain. But to distinguish those two pains is the difficult part. But you know what I'm talking about. We are students of neuroscience. You know what I'm talking about. If you want to build muscle, you cannot build muscle without doing exercise. There is no such thing like that. You need to lift weights, and you're saying, no, I want to gain muscle mass without doing exercise. Then I'm saying, I'm sorry, there is no such method. You need to lift weights, and that, my friends, is a painful process because micro tears happen at the muscle fiber level that is then healed by the body using the glycogen reserves, and with the addition of a muscle fiber in the next within the next 48 hours, one or two fibers, one or two muscle myofibrils, one or two sarcomeres, hundreds of sarcomeres, which is why in the next time you lift, you are able to lift 100 grams more. If you're not able to lift 100 grams more, my friend, you are actually not trying hard enough. Okay, so so that's the story. Okay, are there any other questions? Hamid Kader, any questions? Prasad, Prasad Gainivar, any questions, Prasad? Anvesha, thank you. You are very kind. You are very kind. You also forced me to learn more and more. But like I said, I only know a little bit in a very narrow field. I try to manage with what I know. But I mean, of course, these kind of students always have inspired me to improve myself. The reason why I love interacting with students, the most important reason is because students teach me, and students force me to, to learn more. I love this profession for this reason, because I love learning, and I get to keep learning while making a salary. I don't make a lot, but that's okay. I still do what I love to do. I love learning and I keep learning. Many times students teach me free learning and you get paid for it. What else do you want in life? What can you ask for? Of course, if you love learning, this is great. If you don't, then it's a problem. So, any questions? Prasad, Hamid, Anvesha, other questions? How many people are there? I do not know, because my computer is, the other computer is disconnected. So I'm not able to, I do not know why the other computer is disconnected. I'm not able to fix it on the fly. But I hope we are online. Prajwal, I hope we are online. Please say yes. So, if there are no questions, I thought that we are almost out of time, but that's okay. I thought I'll spend some time talking about the exam. 140 students or so, I think 140 or so students have registered. I'm not having the exact students, the list of students who have registered. I will try to get that list, and I will get in touch with you. Anurag Gupta is saying yes, sir. And by the way, for all of you, Anurag Gupta is my research scholar, but he is not a teaching assistant. He joins every time. I don't know why. He is silently bombing our meetings. That's okay. Why petit mal epilepsy is considered as a disease? God. Epilepsy is a disease. Why petit mal epilepsy? I think these are just types of epilepsy. Grand mal epilepsy, petit mal epilepsy, etc. As to why these are considered as disease, because they are disabling with the seizures are disabling, for example, maybe. Yeah. So, yeah, I thought, 140 or so students have registered for the exam. So we will get in touch with you privately with these 140. We will get in touch with you through the forums. It's important that we need to start preparing for the exam. I hope the exam dates are confirmed. I am not sure of that. I hope they are confirmed, and I hope they actually happen on schedule. My understanding is that the last date for registering of the exam is past. We cannot register for the exam anymore. I still keep getting some emails requesting me if I can extend assignment deadlines, if they can still take the exam, if they can still register. Unfortunately, NPTEL cannot give exceptions to specific students, unfortunately. Because kindly understand that they are a relatively small team that are catering to a very large number of students. I think a couple of million students are taking the courses, and I think about 200,000 or 2 lakh students are taking the exam, or maybe more. I'm just guessing. Just blind guesswork. and they are a team of 40 or 50 people who are doing this phenomenal work. They cannot and they do not have the time and facility to, to make exception for each and every student. Suddenly to open the registration window only for you, suddenly to extend the deadline, assignment deadline only for you. I know this is hard for some of you to understand. You are asking, come on, I'm just asking for one assignment extension. But it's not like that for NPTEL. I request your kind understanding of this matter. It's not possible for NPTEL to do that. Even if I want to do it, actually I also don't want to do it. That's a different story. Philosophically, I do not agree with that, because there are students who are doing this. I still invite you to be part of the class. I still invite you to watch the videos. I'm planning to offer this course one more time the next year, and at that time we will, I welcome you to participate in the course more actively, write the exam and so on and so forth if you have missed the deadline. But please do not ask for exceptions. This is something that NPTEL cannot do, and I also cannot recommend to NPTEL. I do not make these decisions. So that anyhow, we have digressed. The point is that the exam, 140 students have registered, and we must prepare well. We will prepare together starting next week. Maybe we will meet after a couple of weeks, and after that we will meet every week until the exam. Important topics. All the topics are important. I don't teach unimportant topic, Hamid. All topics I teach are just joking. There is going to be coverage. Hamid, I'm serious when I say this. There is going to be coverage of the entire syllabus. Okay, you should take my word on that, because this is something that is required. So there is no important topic, important question. We need to all the topics are important. But what I can do is talk about concepts that are that are important, and once again I'm telling you, you must take my word on this. When I say this, I actually don't know what's on the exam paper. Not that I don't know, I do not remember. I do know, obviously, I do know. I used to know some time ago, but we do this really long time ago. It's not like, tomorrow is the exam, I prepare the question paper today. I forgot. It's been a very long time. In the meanwhile, I'm teaching 3 other courses: physiology for engineers, neuromechanics, this is this course, Neuroscience of Human Movement, offered in IIT Madras in the real mode, in the online real mode, neuromechanics and biomechanics. I'm teaching a lot, so I'm not finding the time to, I do not remember what it is. But what I do remember, what I can help you with are, concepts that are likely to be, questioned, and question types that may be useful. That kind of thing we can do together. We can try to, what I can do is that I can try to post a very small question paper, not a full-scale question paper, something that can be solved in half an hour, 45 minutes. The entire syllabus, 12 or 13 questions. 12 or 13 questions, 12 or 13 weeks content, one question per week type of thing, 12 or 13 questions that you can try to solve before our live meeting, and then I can come and discuss that question paper with you. That's not likely to be on the exam, but it will give you an idea of the type of question pattern, the type of questions that are the difficulty level of the question paper, not the type, maybe, something like that. Could you explain agonists and antagonists? Okay, agonists and antagonists are, Hamid, I hope you took this in the right spirit when I said that all the topics are important, because they are important. Okay, I might be joking, I might have laughed, but that doesn't mean that I was not serious about that. So all the topics are important. Okay. Could you explain agonists and antagonists? So agonists and antagonists are muscles from a particular task point of view. A muscle that accomplishes, helps accomplish a particular task is an agonist for that task. For example, when I'm flexing the arm, the biceps muscle is the agonist, and the triceps muscle is the muscle that acts against this mechanical movement. So the muscle that is responsible for extension is called the antagonist. However, when I am discussing extension movement, when I am discussing extension movement, I am doing that. I am extending my arm like that. When I am extending my elbow, right? Triceps is the agonist and biceps is the antagonist. So agonists and antagonists are muscles that oppose each other in terms of mechanical action. Okay, from a rough viewpoint. Okay, I hope this was somewhat clear for you, Hamid. We usually have a whole bunch of engineers who are here asking me questions about what about brain-computer interface, what is the future of brain-computer interface, what about Neuralink or this. Yeah, right. I don't know, man. I mean, we used to have those kind of these people are not there today. Maybe they have other important things to do. That's okay. We are out of time. Actually, we are out of time. We have overshot our time limit. We are at 5:04. But we started late. That's okay. But I will still end on time. It's my fault that we started late. At least I'll take responsibility one more time. But we'll end on time. It's important because you may have other things to do. Thank you very much for joining. But please do keep writing. Please do keep asking your questions in the forum. And in the you can write to the TA, you can write to me. Please do keep in touch, especially those who registered for the exam. Please make sure that you go to the exam, that you prepare for the exam, that you actually show up on the exam. It's important. I mean, it's not about the 1,000 rupees that you pay. You have made the commitment. We do this because we have committed ourselves. This is crystallization of this is gaining confidence. You have made the commitment, right? And you keep the commitment. When you do that, you gain confidence. You gain more. Your self-esteem goes a little bit up. We all want our self-esteem to go up, don't we? Please, you have made the commitment. Those who have made the commitment, we are going to do that, and we are going to do it really well. We are going to prepare well ahead of time. We are going to sleep the night before the exam. We are going to do well in the exam. Let's resolve to do that, and we are going to actually show up on the exam day. That's important for me. 142, all of you will show up. Nobody will escape. I think, Hamid, you are very kind. I asked you, are you a medical doctor? Or a doctor like me? When I graduated from PhD, one of my committee members said, oh, so am I a doctor? And then he said, oh, not the doctor that helps people or something. So, the doctor that helps people are the medical doctors, those who save lives, those who are fighting the coronavirus war. So, that's my email ID, skam@iitm.ac.in. That's my email ID. You can also Google my name, Varadhan SKM. You can find my email ID. It's not a problem. You are welcome to send me an email. You are welcome to write in the forum. I'm happy to respond everywhere. Maybe I may not be very active in the forum, but I'm watching you, watching the discussions. Your teaching assistant will be active, will be responding, and I will respond when there is a need for me to, pitch in. Thank you, Anvesha. Thank you, Hamid, and the Prasad who joined, Prasad Gainiver who joined, and a few others who are silently watching, and all the students who are going to watch this after the interaction. I understand 4 to 5 maybe you have other commitments, and I'm sure the students will come back and watch it offline. Maybe they are not able to join the live interaction. They will be watching it offline. We will have the next interaction a couple of weeks from now, and after that we will have weekly interaction. We'll try to see. I do not know when the exam is. I'll try to find out when the exam is, and until the exam we'll try to have more frequent interactions, and so that I can coach you for the exam. But remember, it's your exam. It's your exam. It's your course, I'm only a facilitator. So no amount of effort that I put in, no number of live interaction that I have is going to help you. You can help yourself. So it's what I've learned is that you only have to make a decision. This is what I'm learning from my daughter. When she makes a decision, she actually carries through with it, and I'm amazed. Many times she avoids the decision making process, but when she makes the decision, she is amazing at keeping that commitment. Then I tell her, you know what? Why don't you be a bit more decisive? She's only 6 years old. She's only 6. But I'm asking all of you, we have made the decision. We have made the commitment. We'll keep that commitment. Alright. So it's your exam. It's your this. Take extreme ownership. Okay? It's not Varadhan's exam. It's not my exam. It's your exam. Remember that. And I'm just this dude who is asking you to take the exam. And I'm not even sure how well I'll do the exam if I were to take it. It's easy to set questions, man. It's difficult to take exams. Trust me, I know how hard the students find it. It's hard. I know. It's like that. Life, it's like I said, you need to fall down and learn. What other choice do we have? It doesn't seem like there is any easy choice. Can I just lie down in bed and gain muscle mass? You are all students of neuroscience of human movements. You tell me, is it possible? Not possible. So, welcome to the real world. So, please take extreme kindly take extreme ownership of the exam. It's your course. Please. And I'm willing to facilitate. I'm willing to stay with you in the process. Support you in the process. Okay. Thank you very much for your attention. Thanks for joining. It's such a pleasure to interact with students. I love this. I hope you'll make the best use of the time and prepare for the exam, do the course well, do the rest of the course well. My best wishes for for this course and for all the other things that you are pursuing in your life, professional, non-professional, everything. My best wishes. Have a nice holiday season, festival season. Bye bye.